Hey guys, this is Fozon, and today we're going to be discussing wrapper classes, our lesson objectives, learn what wrapper classes are and what their purpose is. We're going to learn about the integer class and its methods, and then the double class and its respective methods as well. So to understand wrapper classes, you have to understand why these wrapper classes exist to begin with. If you recall from our string class video, one of the common misconceptions about the string class is string data type is that people consider it a primitive type in Java when in fact it is not. It just behaves like a primitive type when you instantiate it. You don't have to access the constructor in the string object because you could simply just assign a string to the string object and it works just the same. You don't need to access the constructor. However, primitive types in Java don't have methods that are inherited from the object class. They don't have methods to begin with. So if I were to create an integer x is equal to 5, right, via the primitive type, the instantiation method that we've been doing throughout this course, and then I try to use a method with it, not use a method, if I try to access a method with an integer or double, or even Boolean for that matter, it won't work because we don't have methods there to begin with. Those are not objects. Those are primitive types that the Java compiler or the Java programming language can understand without the use of an object. However, maybe it would be useful to have an equals method, or it would be useful to have a toString method with an integer or double. So this is where wrapper classes come in. What happens, or what we do with wrapper classes, is that we use a value of a primitive type and then we wrap it up into an object. So we're basically converting an integer primitive type, right? An integer primitive type into an integer object. We no longer have, we do have it. The integer object does have the integer primitive type as an instance variable, but I want you to understand this. Once we wrap it into an object, now we have methods that we can use. It allows us to use more methods. And if you have more methods, you have more, functionality that you can use in your algorithms. And there's even a way of unwrapping it. So if you want to convert it from an object back into its primitive type, there is a method for that. In this video, we're going to be discussing an integer and double class. So let's first start off with the integer class. What the integer class does is that it wraps the primitive type int. Int is the only instance variable within the integer class. But once you wrap it into the integer object, now you have certain methods that you can use that are part of the integer class. You have a, constructor to actually construct it. You have a compare to method. You have an int value method. And you also have an equals and toString method that is inherited from the object class. And like I said from the object class video, the object class is the superclass of the universal superclass of every single class. So it's going to inherit the equals and toString method. So how do we wrap the integer primitive type into an integer object? Well, we do so via the constructor like we do when we're creating most objects. So we have an integer, my integer, and we set that equal to new integer. The new, this keyword emphasizes that we're accessing the constructor of the integer class. And then in the arguments of the constructor, we put the integer value, the integer primitive type that we want to wrap up into an object. And then once we do this, we can use the myInteger identifier to access certain methods that we want to utilize within our algorithm. It's a little bit slow there, so hopefully it will load. Okay, so let's discuss the integer class methods excluding the constructor since we just discussed the constructor. Well, we have the integer compared to method, and what it does is literally what it did in the string class video, except it only has 3 return types rather than returning a value that is dependent on their location in the alphabet. So we have a compared to method, and it takes an integer argument, and if both integers are the same, meaning that the integer that you're comparing it to is the exact same integer, it's going to return it's going to return 0. It returns an integer, so you could store it as an integer. You can If the number is less than the other number, it's going to return -1. And if it returns 1, well, then the number that you have is greater than the number that you're comparing it to. Again, we'll test this out in the compiler and hopefully it will make sense, because then we could drill down on how different -1 and 1 return values are. You'll also have the unwrapping method of the integer class, aka the int value method. And what this does, it simply returns the value of the integer object as an integer. So now you're converting from an integer object being the integer that has all the methods, back into its primitive type. The primitive type being the one without any methods. So you're converting it from an integer object to an integer once you access the int value method, and then you can store it as a primitive type by creating another integer x is equal to, you're accessing the integer object and then int value method, and that's how you unwrap the integer value from the integer object. You're converting from an integer object to an integer. Again, it will make more sense with the compiler because then you could see it in real time. You have the equals method that is inherited from the object class, and unlike the object class, however, the way that this one works is a little bit different. So if you remember from our object class video, what did it do? Well, what it did was that it would compare the memory location, and if they were not the same memory location, it would return false. That is not really practical when we're comparing integers and seeing whether or not they equal to each other. So this one is actually overridden. So it's inherited from the object class, but it's overridden. And what can we do? Well, if the integers are the same, it will return true. If the integers are not the same, then it's going to return false, irrespective of where they're located on your computer. Speaking of the object class, we also have another method that is inherited from the object class. It's the Tostring method, and what this does, it returns the integer as a string version. It's not the same as the int value method, because what did the int value method return? It would return the integer primitive type as the return type, whereas the Tostring method, it returns a string. Those are two different things. This method, the Tostring method, returns a string, like it says in the method name, but the int value method, it returns an integer. You also have two static variables within the integer class, and you could use this within whatever algorithm you develop. You have a integer min value, and since these are static variables, you access it through the class name, not the identifier, by creating an object. So you could just simply access the static variable by calling it integer.min_value, min value being capitalized or max value also being capitalized, and then this will just simply access the largest value or the minimum value that you can store as an integer. Now the double class does exactly what you think it does based on what you learned from the integer class. The double class, it wraps the primitive type double into an instance it wraps the primitive type double into a double object, and then double is the only instance variable. So with double being the only instance variable, you're wrapping it up into an object, and now that you have a double object, you can access a bunch of methods that you can use in your algorithm. You have the constructor, you have the compare to method, you have the double value method that unwraps the object. You also have the equals method that is inherited from the object class, but overridden to see whether or not they're actually the same number rather than the same object location. And you also have the Tostring method that converts the double into a string. So let's test this out into the compiler to make sure that it's understandable. So we're in the compiler, and let's create an integer object. So the first thing I'm going to do is show you that this is the primitive type. So the way that we do the primitive type is like we've always done. Integer x is equal to 5, right? And when we, print statement, when we print this out, print ln, let me do print ln, and then I access it, what happens? It prints out, well, 5 because that's our integer x. However, if I want to access maybe a toString method, what happens? Actually, it would make more sense if I create a string x to show you. String x. So if I create a string y, not string x because we already have an identifier named x, and we try to access the toString method, what happens? So when I try to print out y, it's going to hit me with an error or an exception rather, because x does not have a toString method. Since x does not have a toString method, what do we need to do? We need to create a wrapper class. So let's create a integer object. Create integer object. And how do we create an integer object? Well, we do integer, right? That's the name of our class. And then we have our identifier, so I'm going to name it as my integer. And I'm going to set that equal to, and then we're going to access the constructor of the my integer class, and then the arguments that it takes is, well, the integer, the primitive type integer. So I put x because that's my primitive type that I want to wrap. So this wraps 5. Please ignore the strike 2 text over there. So now, if I try to access the toString method, string y is equal to my integer, because now I'm accessing the integer object, not the integer primitive type, and then the toString method, all of a sudden, once I execute this program, once I save it, it now works because we're now getting a string value from the toString. First of all, my integer actually has a toString method. That's important to know because it's an object. Since this is an object and it's extended from the object class, it has the toString method that they override it, and that allows it to work. The primitive type, it does not have this primitive type thing over here. It does not have a toString method. Let's do the compare to method. So what does the compare to method return? The compare to method returns an integer. So compare to method. The compare to method returns an integer. So let's do integer z, and we're going to set that equal to my integer dot compare to. Let me see, and then let's print out z. And what number should we compare it to? Well, let's compare it to the value that it has currently, 5. And hopefully it should print out 0, because that is the value, or rather 5 is the exact same thing as 5, since 5 is, well, equal to 5. But let's say if we put a number that's greater than my integer. If we put a number that's greater than my integer, it should return -1, because my integer is less than the value that you're comparing it to. So if it's less than the value that you're comparing it to, then it's going to return -1. However, if it's greater than the value that you compare it to, it's going to return 1. And this is irrespective of how much the difference is. So even if I put, let's say, 0, it will return 1. It does not account for the difference between the values. It just sees which one is greater, which one is equal, and which one is, well, less than. We also have the equals method, and what the equals method allows us to do is access or return the Boolean value to see whether or not if the values are equal to each other. So if we have, let's say, a Boolean z, actually let me do Boolean a and change this into an a. We have Boolean a, and we set that equal to my integer dot equals, and then if we compare it to, not compare since compare is an actual method, if we access the equals method with the arguments 5, what should return? It should return, let me make sure that this works, I forgot the semicolon. It should return true because, well, 5 is equal to 5. But if I put a number that is not equal to 5 or not equal to the value that we wrapped within our my integer, it should return false. and it returns false. Let me clean up this clutter. Okay, and let me clean up this clutter. Finally, what happens if we want to unwrap the value? We want to extract the value from, this myInteger object. Well, we access the int value method, and that returns an integer value. So we do integer a, and we set that equal to, and then we access the identifier that we have the integer object stored at, and then we access the method int value since it returns our integer value. And hopefully this will print out 5. But it prints out the integer primitive type rather than the integer object. And just a side note, because you might use this in your algorithms and future problem sets or whatnot, if you want to access the integer max value, you do integer dot max value, and the reason why that you access it through that rather than creating an integer object is because max value as well as min values are ultimately static values, and static, as you recall from our private public static video, it does not require an instantiation. You can make it work, but you have to make sure that it's within a static context. And in this case, we access the integer class, not an integer object, and then we access the max value data field, and a min value static variable. And it prints out the respective minimum value and the maximum value of the integer class. We can also do the same with the double class. So let's say if I want to, let me erase all this, and let me keep the 2 comments here because they're pretty much going to be the same with the double class. So we can declare double value. Let's actually label this double pi, and we could label it as assign 3.14 into pi. And instead of, well, creating an integer object for a integer primitive type, we're going to create a double object for a double primitive type. We access the constructor. Inside the parameters, we put in our double primitive type. Now we've wrapped our double value into an access the Tostring method of, if we were trying to access a Tostring method of the primitive type, what will occur? Well, we can't do that because Tostring does not exist within the double primitive type, but it does exist within the double object. Let me adjust this comment. Creates a double object. So if I were to replace the identifier with our double object rather than our double primitive type, it should hopefully work. As you can see, Tostring is now colored, meaning that it should work. And then when we create it, it actually prints out 3.14. And just to show you that we can store it into an integer, we can store it into a string. Let me create a string x, and let me copy that, paste it there, then print out x. Let me add a semicolon so that it works, and we can run the program, and it does the same. If you recall from one of our previous videos, what happened when we tried to simply put pi in there? Well, we get an exception because you cannot convert from a double to string. So what we would have to do is we would have to add an integer, add a string, and hopefully it would have made it much better. However, it's much easier knowing that we have a class that we can wrap up the double. Now the double is wrapped, we can access different methods, especially the Tostring method that converts our double into a, well, string. And again, just to show you that it works just as it does. We can also use the compare to method with our double value. So if I access Let's change this from string to integer, since the compare to method returns an integer. And then I want to compare my double to, let's say, the exact same number. It should hopefully print out 0 because these two numbers are exactly the same. But if I put a number that's greater than the number that if we're comparing a number to a much greater number, what will occur? It should be -1, because the number that we have is less than the number we're comparing it to. But if the number that we have is, well, greater than the number that we're comparing it to, let me make this 3.13, it's going to return 1 because my double is greater than the value within our arguments. And you could put an integer, you can put a double there, a double variable there, and it will work just the same. We also have the equals method. So what does the equals method return? It returns a Boolean expression, or Boolean value to be more specific. And when we're accessing the equals method, it takes in the arguments that of a double, and then if we try to access it, it will be true if we have the same value. So 3.14 that we wrapped up inside our my double object is equal to, well, 3.14 that we have within the arguments. However, if I don't have 3.14, let's say if I have 3.10, a value that we have that is different from the value that we wrapped up, then it will return false. Finally, let's unwrap our value. So if we unwrap the double object, meaning that we're trying to convert it from a double object to a double primitive type, just like how it's declared here, we could use the double value method of the double object. Let me make sure that it's double object there. Okay, so how do we declare a primitive type with like this? We have double, and then we could do unwrap, that I'm going to label it, and then we're going to set that equal to what is the object that we have currently. We have my double as our object, and what method allows us to convert it from a double object to a double primitive type. Well, we have double value. Oh, I spelled that wrong. Let me make sure that this is spelled correctly. Okay, there you go. We have our semicolon. Let me adjust the print statement to reflect our new unwrapped value, and it should print out 3.14. However, it's not printing out the double object, it's printing out our double primitive type. I hope you enjoyed this video on wrapper classes. They're very powerful in terms of having methods more readily available to us with our primitive types, rather than trying to use different types that are already available to us with the Java compiler. We have methods that are inherited from the object class, as well as a multitude of other methods that are created within the integer and double class that allow us to make more useful algorithms. So I hope you enjoyed this video.